Yeah, this is Dr. J. Mohan, Department of ECE. Today I'm going to discuss about the Fourier transform, fourth session. This will be under the topic of signals and stochastic processing. This is today presentation outline is Fourier transform of sine function, Fourier transform of cosine function, property of Fourier transform. In this section, we should discuss about the only three property with some examples. First property is linearity property of Fourier transform, frequency shifting property of Fourier transform, time reversal property of Fourier transform, and references. Before going to the Fourier transform function, the Fourier transform it came from the Fourier series only. Fourier series it's analyzed for the only periodic signal, but Fourier transform it's need to analyze for the non-periodic signal also. So last class we will be discussed about the so many different kind of signals for unit signal, exponential signal, parabolic signal, as well as a triangular signal, square signal, a rectangular signal. All signal we studied. So those signal it will be going to generated for the time domain into frequency domain to using the Fourier transform. In the frequency domain, it's not possible to realize. So that's why we went for the magnitude as well as a phase response. So this class also we should go for the Fourier transform in two different kind of signal. One is sine as well as a cosine function. First case, we should go for the sine function. We know the sine function is represented as a x of t equal to omega 0 t. That is x of t equal to sine omega 0 t. Omega 0 is represented as a frequency response. T is called for the time response. This x of t sine omega 0 t is not possible to directly make to realize for the Fourier transform. So we need to convert for the x of t is equal to sine omega t as a exponential order. That's why we go for the Euler rule. The Euler rule states that x of t is equal to sine omega t, omega 0 t is equal to e power j omega 0 t minus of e power minus j omega 0 t divided by 2j. So we studied for the Euler form like sine of theta is equal to e power j theta minus e power minus of j theta divided by 2j. This notation is used for the Fourier transform condition. So this is called for the Euler rule. Now we go for the Fourier transform to convert for the sine omega 0 t using the definition of Fourier case f of x of t, that is f is called for the Fourier transform. X of t is equal to x of omega we should write. This x of omega it's represent by the Fourier transform the case of integration of minus infinity to plus infinity x of t e power minus j omega t dt we should write. Okay, so this is called for the Fourier transform. So this Fourier transform we should adapt it for the sine function. Now I should write as a sine function f of sine omega 0 t equal to x of omega. It's equal to integration of minus into plus into x of t e power j omega t dt. Now I should write for the x of t is represented as a sine omega 0 t. That is equal to integration of minus into plus into sin omega 0 t e power j omega t dt. We know this term we should write for the Euler form, that value is equal to, the sin value is equal to sin omega 0 t is equal to e power j omega 0 t minus of e power minus j omega 0 t divided by 2j. We should substitute here instead of sin omega 0 to here. The next step, the x of omega equal to minus 2 plus 2 e power j omega 0 t minus of e power minus j omega 0 t divided by 2j into e power j omega t dt we should write. Now, this 2j we take it out from the integration. So that x of omega is equal to 1 by 2j integration of minus 2 plus 2. At the same time, we should split for the, this term is separate and this term is going to separate. Okay, plus term as well as a minus term, both will be going to need to separate for the e power exponential values. Now I should write this term into this term is separate. Another case, this term into this term is separate. This term is represented as a, take it out from the integration because it's not possible to do by integration. It is only the constant value. So that's why 1 by 2 pi j integration of minus 2 plus 2 e power j omega 0 t e power minus j omega t. See this total, this term as well as this term instead of dt. Next, this minus I should write here integration of minus 2 plus t e power minus j omega 0 t e power minus j omega t dt. Now we can simplify for this case. To make a integration, I write as a 1 by 2 pi j f of e power j omega 0 t minus of e power, that is f of e power minus j omega 0 t I should write. So now this 2 is represented as a Fourier case. This whole term I synced for the Fourier of e power j omega 0 t. This is e power of this term, that is minus of e power of minus j omega 0 t I write here. So that's why finally I make as a, the frequency domain of x of omega is equal to 1 by 2 pi j f of e power j omega 0 t minus of f of e power minus j omega t. The Fourier transform of complex exponential function, we know already, we discussed for this one last section. If you have the complex exponential function, then that will be automatically it's going to convert it for the del condition. How much it will be going to happen? What the exponential value of omega terms present, that much time it will be going to shift. So that's why I remodify for this equation as f of e power j omega 0 t is equal to 2 time of pi del of omega minus omega 0 and f of e power minus j omega 0 t is equal to 2 pi of del of omega plus omega 0. So now this two we studied for the last session. So don't want to discuss now. That directly we can adopt it for the exponential function, that is a complex exponential function to this equation. Now it will be modified like this one. 1 by, that is x of omega is equal to 1 by 2 pi j. Here, that is a first term. This first term is represented as a f of e power j omega 0 t. So that's why 2 pi del of omega minus omega 0 t. This term, this is minus. After that, this term f of e power minus j omega 0 t, that will be called 2 pi del of omega plus omega 0. Now this 2 pi take it out. Yeah, the 2 pi take it out from the both the resultant value. So the 2 getting to cancel. The j is came for the upper minus, then pi it will be have the constant. That's why finally I write as a x of omega is equal to minus of j pi del of omega minus omega 0 minus of del of omega plus omega 0. This is a Fourier transform of sine function. So I should write for the Fourier transform of sine omega 0 t is equal to minus j by del of omega minus omega 0 minus del of omega plus omega 0. Or we should write for the another way also. Sine of omega 0 t, a Fourier transform that both the direction minus of j pi del of omega minus omega 0 minus del of omega plus omega 0. So this is we call for the sine function Fourier transform. Now this sine function Fourier transform, it's not possible to represent for the uh, waveform. So this is going to showing for the amplitude values. So even though we need to represent for the waveform, that's why we must do for the two things. One is represent as a magnitude, another is represent as a phase. What the magnitude? The magnitude I represent as a magnitude represent as mod value. So the input is x of omega. So that's why I can simply write for this case as capital letter x of omega mod is equal to root of real part square plus imaginary part square. Real part square as well as of imaginary part square. So if I make for the magnitude response, okay, if make for the magnitude response is represented as a pi as well as a plus pi. Okay, so the real value of minus omega location is represented as a pi, then plus omega location is represented as a pi. Pi because of here only pi. These two getting to cancel because of this is impulse version. The impulse version of magnitude response is equal to 1. So only pi is present. So now I write for the magnitude response of a sine C function. The magnitude value is magnitude spectrum value is represented as a mod of x of omega. So the minus omega side would be other plus pi, plus omega side also would be other plus pi. Now we can see we got for the this portion of magnitude 1 in the sine function. Next, we go for the phase response. This is a phase response of sine omega 0 t. So when the negative side of omega 0 t is represented as a pi by 2 and positive side will be represented as a minus of pi by 2, then sine wave it will be started for the 0, it's continue after some time duration, some period, again it will be another sine wave is going to happen. These are the graphical representation of sine function with magnitude as well as of space spectrum. Next case, we should go for the Fourier transform of cosine function. The cosine function I should write x of t is equal to cos omega 0 t. For the this cos omega 0 t is not possible to make for the Fourier transform. That's why we go for the Euler rules. The cos theta, we know the Euler rules of cos theta is equal to e power j theta plus e power of minus j theta divided by 2. So this case of Euler form we can adapt it for the sine omega 0. In the due to this theta it will be half for the omega 0 t. Now I should write for the Euler form of cos omega 0 t is equal to e power j omega 0 t plus e power minus j omega 0 t divided by 2. Now you take for the Fourier transform of x of t in the case of cos omega 0 t. Now the Fourier transform of x of t is represented by Fourier transform of x of t is represented by frequency signal x of omega. Okay, then that will be minus into plus into x of t e power of minus j omega t dt. I should write. Now in system of x it's equal to cos omega 0 t. Now we can substitute Fourier transform of cos omega 0 t is equal to x of omega is equal to integration of minus into plus into x of t e power minus j omega t dt. Then this x of t is equal to cos omega 0 t. So that's why the equation is going to convert it for integration of minus into plus into cos omega 0 t e power minus j omega t dt. Now we know this formula, this cos omega z is R left case. The next step that where they're going to have for the cos omega 0 t, we should substitute for this value. See for the next step, the x of omega is equal to minus into e power j omega 0 t plus e power minus j omega 0 t divided by 2 e power of minus j omega t dt. Now we can split both for real value as well as of imaginary value from this equation. So this 1 by 2 is going to have the constant. That's why I take it out. Then 1 by 2 into integration of minus into plus into e power j omega 0 t. This term with this term e power j omega 0 t into e power minus j omega t dt. The next side is a plus. That's why we going to have the plus. This side plus plus. Then e power minus j omega 0 t e power j omega t dt we can write. Now this term, this entire term, the 1 by 2 we can write it for the next step. This entire term we call for the e power j omega 0 t of Fourier transform. So this term it will be the Fourier transform of e power minus j omega 0 t. So that's why simply I write like this form. 1 by 2 f of e power j omega 0 t plus f of e power minus j omega. We know the f of e power j omega 0 t we studied for the previous case of exponential condition. So now that case x of omega is equal to 1 by 2 pi 2 pi del of omega minus of omega 0, this value. Okay, this is represent. So this 2 pi is going to taken from the your Fourier transform condition. So this side, this one, it will be plus up to pi del of omega plus omega 0. If you take it for the 2 pi in both side, what will be half? X of omega is equal to pi of del of omega minus omega 0 plus del of omega plus omega 0 we got. So this after that Fourier transform of cosine wave I should write Fourier transform of cosine wave is equal to pi of del of omega minus omega 0 plus del of omega plus omega 0 or else we write as a cos omega 0 t Fourier transform is equal to del of omega minus omega 0 into pi plus del of omega plus omega 0. This pi is common for both the term. Okay. Now we can draw for the magnitude as well as a phase response. So now if we take for the magnitude response of cos omega t, value is equal to pi for negative side and positive side both. So that's why magnitude value it will be present for the pi to minus pi. That is a plus pi to minus pi. That is called for the omega 0 to minus of omega 0. This is we call for the magnitude spectrum. Next we go for the space spectrum. Space is represented, that is a theta value, it will be have the tan inverse of imaginary part divided by real part, that is p by a we are writing. So now there is no imaginary part here, that's why it's represented as 0. So due to that condition, the angle is always going to keep for the both omega 0 minus of omega 0, even though it is represented as there 0 only. This is magnitude and space spectrum of cosine signal. Next case. This is very important for exam point of view as well as of understanding purpose of Fourier transform. The property of Fourier transform. The first property is represented as a linearity property of Fourier transform. The linearity property of Fourier transform state that the linearity property of Fourier transform state that the Fourier transform of weighted sum of the two signal is equal to the weighted sum of the individual Fourier transform. It's called for the linear property of Fourier transform. As per the Fourier transform, we should take for the we need to prove for this property, we should take for the two type of signal. One is I taken for the x1 of t and another one is x2 of t. Both it will be have the time domain. Then we take for the Fourier transform, then we got for the x1 of omega. If we take for the Fourier transform of x1 of t, we got for the x1 of capital letter x1 of omega. That means the Fourier transform is going to convert for the time domain to frequency domain. Next, another signal we take for the x2 of t, take for the Fourier transform, it's produced for the capital letter x2 of omega. Then according to the linear property of Fourier transform, algebraic, that is represented as a sum of weight of two signal is equal to sum of weight of individual cases. So now the sum of two signal, what is that? I added for the some magnitude value, that is a x1 of t plus b x2 of t take for the Fourier transform. We got for the frequency domain as a x1 of omega plus b x2 of omega. This means it will be going to represent for the sum of their individual Fourier transform. These are the sum of individual Fourier transform. Here a and b is represented as arbitrary constant. Then we go for the proof. From the definition of Fourier transform, f of x of t is equal to x of omega integration of minus into plus into x of t e power minus j omega t dt. Now, then x of omega equal to f of a x1 of t plus b x2 of t equal to summation integration of minus into plus into a x1 of t plus b x2 of t e power j omega 0 t. Now we can split for this one for based on the our input two inputs. So integration of minus into plus into a x1 of t e power minus j omega t dt plus integration of minus into plus into b x2 of t e power minus j omega t dt. Okay. Now we can do for the integration in separate. We take it out for the constant. A and b are constant. We take it out. So we do for the integration for this one. Again, this term b take it out. Do for the integration for x2 of t e power j omega t as well as of x1 of t e power j omega t. Now this term is represented as x1 of x2 of omega. Okay. So this term I should write as a x2 of omega as per the statement of Fourier transform. Then this term I should write as a x1 of omega. So this a and b is a constant. I should write as a x1 of omega, b x2 of omega. Or we should write for the formula Fourier transform of a x1 of t plus b x2 of t is equal to a x1 of omega plus b x1 of x2 of omega. It can also be write as a x1 of t plus b x2 of t. Fourier transform is equal to a capital letter x1 of omega plus b capital letter x1 of x2 of omega. So both it will be represented as a frequency element a x1 of omega plus b x2 of omega. Now what it be going to represent? Sum of, as per the statement of linear property, the Fourier transform of weighted sum of two signal is equal to weighted sum of their individual Fourier transform. Okay, this is represented as a statement. This statement is going to satisfy for here. So now the linear property of Fourier transform is getting to satisfy. Then next property is represented as a frequency shifting property of Fourier transform. The frequency shifting property of Fourier transform states that the multiplication of a time domain signal x of t by exponential cases the frequency spectrum to be shifted. Okay, if time spectrum, if you are going to multiply for the input side e power j omega 0 t, the frequency automatically shifted together. Now, as for the Fourier transform, I should write for the Fourier transform equation x of t is equal to Fourier transform of x of omega. Okay, and according to the frequency shifting property, we need to multiply for the e power j omega 0 t into x of t. That value is represented as a capital letter X omega 0, omega minus omega 0. This is called for the time shifting property of Fourier transform. I should say another time, e power j omega 0 to x of t, the Fourier transform is represented as a x of omega 0. Next, based on the definition of Fourier transform, I should write for the f of x of t is equal to x of omega. Now this x of omega is represented as a integration of minus into plus into x of t e power minus j omega t dt. Now the instead of x, we should take in for the e power j omega 0 t x of t. Now we need to do for the integration. The integration is represented as a minus into plus into e power j omega 0 t x of t into e power minus j omega 0 t dt. So now x of omega equal to integration of minus into plus to x of t e power minus j omega minus omega 0 t dt. This term already we studied, that shifted version case. So it's produced for the output is x of omega minus omega 0. Now, the Fourier transform of minus of e power minus of j omega 0 to x of t is equal to capital letter x of omega minus omega 0, or e power minus j omega 0 t x of t is equal to x of omega plus omega 0. Here, if we got for the plus, you should write for the minus. If you got for the plus, you write for the minus of frequency domain. Okay. Next, we should take some example. Using the linear and the frequency shifting property of Fourier transform, find the Fourier transform of cos omega 0 t u of t. The cos omega 0 to u of t, we can write, we know cos omega 0 t as using the Euler formula. Cos omega 0 t equal to e power j omega 0 t plus e power minus j omega 0 t divided by 2. Now, you take for the cos omega 0 t. Okay, this cos omega 0 t, it's need to adapt for the u of t also. Then e power j omega 0 t plus e power minus j omega 0 t divided by 2 into u of t. As for the Fourier transform, the formula f of x of t equal to x of omega. So that case, we need to substitute for the x value, that f of cos omega 0 t u of t, that is e power Fourier transform of e power j omega 0 t plus e power minus j omega 0 t divided by 2 into u of t. Then using linear property, what is the linear property? Its weighted sum of the individual input is equal to weighted sum of the corresponding output of Fourier transform. So that statement I should write as a x1 of t plus b x2 of t. Fourier transform of a x1 of omega plus b x1 of omega. Now in this condition, we multiply with some coefficient, that is sum of Fourier transform of individual signal, that is represented as a with constant x1 of t plus b x2 of t, that is equal to Fourier transform is equal to a x1 of omega plus b x2 of omega. So now, as per the statement of condition, f of cos omega 0 t u of t is equal to 1 by 2 e power j omega 0 t u of t plus 1 by 2 e power minus j omega 0 t u of t. This 2, it's going to satisfy for the frequency shifting property. So that's why I write as a simple frequency shifting property as e power j omega 0 t x of t is equal to, that is a Fourier transform is equal to x of omega 0 t. Now, f of cos omega 0 t ut is equal to 1 by 2 u of t when omega is equal to omega 0 t. See here omega 0. Then second step, 1 by 2 f of u of t is equal to, or omega equal to omega plus omega 0. We can substitute for here, that finally we got 1 by 2 as a time shifting property pi del of omega minus omega 0 plus 1 by j omega minus omega 0 plus pi del of omega plus omega 0 plus 1 by j omega plus omega 0. So now I can simplify for this equation. We got for the output as 1 by 2 pi del of omega minus omega 0 plus pi del of omega plus omega 0 plus 2j omega divided by omega 0 2 minus of omega 0. The Fourier transform of given signal. Okay, the Fourier transform of given signal f of cos omega t u of t is equal to 1 by pi del of omega minus omega 0 plus pi by 2 del of omega plus omega 0 plus j omega divided by omega 0 square plus j omega square. The next property is represented as a time shifting property, Fourier transform. The time shifting property of Fourier transform states that if the signal x of t is shifted by the t time domain, the frequency spectrum modified by the linear phase shifting of slope. So this is called for the time shifting property. Now we take for the Fourier transform in the general condition x of t. Its take Fourier transform is produced by the x of omega, Another case x of um, t minus of t0, that is time shifting version. As per the statement, Fourier transform is going to multiply it with the e power j omega 0 t x of omega. Now, how many time you are going to shifting that frequency, that many time it will be going to get to multiply. As the definition of Fourier transform, we write as f of x of t equal to x of omega is equal to integration of minus plus to x of t e power minus j omega t dt. Now, the Fourier transform of the x of t, you can substitute for the t minus of t0. Fourier transform of x of t minus of t0 equal to integration of minus plus to x of t minus of t0 uh, e power minus j omega t dt. Now, we can substitute t minus t0 is equal to u, then t equal to u plus of some leaf. Then t minus of t0 equal to u, then t is equal to u plus of t0 from this equation. And we take further differentiation, that is d by dt. This is constant, that's why there is no change of t0. Then u only is going to getting to change. D by dt is represented as du. You can substitute this all the values, this value, and this value into this equation. Finally, we got f of x minus of x0 is equal to integration of minus plus p x of u e power minus j u minus plus of t0 du. Now, next step, you take it out for the e power minus j constant. What are the constants are that? T0. Take it out. E power minus j omega t0 integration of minus plus into x of u e power minus j omega of u du. Then if we take for the integration for this equation, it's multiply with e power minus j omega 0 t omega t0 x of omega. Then this case we can write for the another form, that is Fourier transform of x of t minus of t0 is equal to e power minus j omega t0 x of omega. Similarly, we can write for the another form also. Here is how the minus, here I use for the t x of t plus t0. Then the Fourier transform is equal to e power j omega 0 t0 x of omega. This is represented as a time shifting property of Fourier transform as a condition. It is very important for the implementation that we must find for the magnitude as well as the phase response. Magnitude response nothing. The modulus value of what we are going to find e power j omega 0 t, then that value is equal to magnitude response. So now the magnitude response is represented as e power minus j omega 0 t x of omega equal to x of omega. The phase response, angle of e power minus j omega t0 x of omega is equal to e power minus j omega 0 plus angle of x of omega. So this term is represented as the angle of minus of omega t0 plus angle of x of omega. It is clear that the time shifting of function by in t0 time domain, the result in multiplying its frequency transform by e power j omega 0 t0. Hence, there is no change in the magnitude spectrum, but space spectrum is always shifted. How much shifted? That is minus of omega 0 t deviation. Okay. So I said another time, it is a clear that the shifting of function by t0 in the time domain result in a multiplying its Fourier transform by e power j omega 0 t. Hence, there is a no change in the magnitude spectrum, but the space spectrum is going to change. So here I will write the magnitude spectrum is always is representation mod of omega. Phase spectrum is addition with some exponential base. Okay, we take further one example using the time shifting property of Fourier transform. Find the Fourier transform of signal e power minus a t minus of 2. So this term, this period, I'm going to give for the Fourier transform of shifted version signal e power minus a t minus of 2, that is e power minus a mod of t I should take for here, but that means it is a two-side exponential signal. Okay, if we take for the Fourier transform of two-side exponential signal, we know well that is Fourier transform of e power minus a mod of t is equal to 2 time of a divided by a square plus omega square. By using the time shifting property, e power minus a mod of t minus 2 is equal to e power j 2 omega, it's taken out, then remaining thing is represented to a divided by a square plus of omega square. It can also write as e power minus of a mod of t minus 2 is represented here in terms of Fourier transform e power minus j 2 omega in bracket 2a divided by a square plus omega square. Up to this much, I'm going to stop my this session. Okay, so even though time reversal property also is there, so this is a time shifting property we use for the two-side modulation. Then next property is represents a time reversal property of Fourier transform. The time reversal property of Fourier transform state that if a function x of t is a reversal in time domain, then the spectrum frequency domain also reversal. That means time domain, if you are going to reverse, the frequency spectrum also reverse together. So we know x of t of Fourier transform is equal to x of omega. That means time domain to frequency domain conversion. X of minus t, take for the Fourier transform, it's getting for the x of minus omega, capital letter x of minus omega. Why? Because of the time shifting, that is not time shifting, this is time reversal in the input. The output frequency domain also time reversal is going to happen. And the definition of Fourier transform of f of x of t is equal to x of omega. That value is equal to integration of minus plus t x of t e power minus j omega t dt. Then here input I am going to change with the time. That is f of my x of minus t is equal to integration of minus plus t x of minus t e power minus j omega t dt we got. Okay. So this is the Fourier transform. Now we need to analyze or we need to integrate. Instead of minus t, we should take for the plus t. Okay. By minus t in the RHS above the equation, we can write we given for the minus t into minus t to substitute here. That's why the Fourier transform of x of minus t is equal to integration of minus plus t x of t e power minus j omega t dt. Then f of x of minus t is equal to integration of minus plus t x of t e power minus of j minus of omega t dt. Then we write for the x of minus omega. If we need to Fourier transform of time reversal condition in the time domain f of x of minus t, then it's produced the output is x of minus omega. Or we can write another form x of minus t of Fourier transform is equal to x of minus of omega. Okay, we take some example for this time reversal property also. The Fourier transform using the time reversal property, find the Fourier transform of u of minus t. X is equal to u of minus t. That is, what is it? It is a time shifted. That is time reverse function. Shifted reverse function we going to occur. So u of t we know that is called for the unit step function. Then f of u of t is equal to minus of del of omega plus 1 by j of omega. This will be studied in class. Now, based on this notation, we should solve by the equation. Then using time reversal property, minus of x of t for x of minus, that is x of minus t Fourier transform is represented as x of minus omega. Now, we take for the Fourier transform of u of minus t is equal to f of u of t. The omega is equal to minus of omega. Then I should write for the equation f of u of minus t is equal to pi del of omega plus 1 by j omega. This value I need to simplify. The omega we know omega equal to minus of omega. You substitute for the omega equal to minus omega. Then the result is pi del of minus omega plus 1 by j minus of omega. Now I should modify for your equation f of Fourier transform of u of minus t is equal to del of omega plus 1 by j omega, or u of minus t Fourier transform is represented as in pi of del of omega minus 1 by j omega. We may write, okay, this two term. So these topics are I referred from these two books. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.